Okay, welcome to a significant historical milestone in this channel. I'm about to finish reading front to back my second RFC. Um, Previously, I had read the BGP RFC, and then I'd say the other biggest milestone was taking that JNCIE SP, even though I failed it. But this is kind of more the direction I want to take this channel in, because the advantage to reading these RFCs are, the biggest advantage is I can go back to the RFC and reference it on the job, studying for another cert, that sort of thing. Kind of my preferred way to learn about things is out in the open, as is evident by this channel. If things are kind of locked away and inaccessible, I find it's just harder to reference, and it's harder to kind of get people to believe you well, I mean, even if you kind of convince people you're an expert, you're going to be expected to actually demonstrate that. So if you lost your notes or you don't have them readily accessible, it can be a lot more difficult to demonstrate that than if it was just out in the open like these RFCs are. So that's a big reason why I'm focusing on these as part of this channel, along with many other reasons which I have discussed previously. Okay, so the last section of this RFC is section 6, 7, 8, and then 9 and the appendix are just short sections. So yeah, and 7 and 8 are short as well. So let's dive right into it and finish up this RFC. Section 6 is Internationalization Considerations. So this would be for multiple regional internet registries. There is value in supporting the ability to submit either a U label, Unicode from an IDN label, or an A label, US-AS, the ASCII form of an IDN label. And one of the advantages of a U label that I can think of right off the bat, if you have a language like Arabic, like Japanese, Chinese, even some European languages that have like the special dots over the characters, those can't be represented in ASCII, because ASCII is it's an encoding for the English alphabet. Primarily, there's other characters as well, but Unicode is the encoding that accounts for other characters that are not present in the English alphabet. So that's why you would want Unicode over ASCII. Yeah. So clients capable of processing non-US ASCII characters may prefer a U label, since this is more visually recognizable and familiar than A label strings, but clients using programmatic interfaces might find it easier to submit and display A labels if they are unable to import U labels with their keyboard configuration. Both query forms are acceptable. Internationalized domain and name server domains can contain character variants and character labels as described in RFC9290. Clients that support queries for internationalized domain and name server names must accept service provider responses that describe variants as specified in JSON responses for registration data access protocol. Okay, so section 6.1, I've got like dry mouth. I'm going to be talking for a while, so I'll be back shortly. Okay, I'm back. Next section is character encoding considerations. Servers can expect to receive search patterns from clients that contain character strings encoded in different forms supported by HTTP. It is entirely possible to apply filters and normalization rules to search patterns prior to making character comparisons, but this type of processing is more typically needed to determine the validity of registered strings than to match patterns. An RDAP client submitting a query string containing non-US ASCII characters converts such strings into Unicode in UTF-8 encoding. It then performs any local case mapping deemed necessary. Strings are normalized using normalization form C, NFC. Note that clients might not be able to do this reliably. UTF-8 encoded strings are then appropriately %coded in the query URL. And this doesn't look like an RFC, it looks like a technical report, but I don't think I'm going to keep that. It's just a little bit too I just don't ever see this being like relevant to me. So yeah, I'm not going to keep it. And these RFCs primarily are only relevant because I'm making it a goal of this channel to read through as many as I can. So even these are perhaps not all that relevant. After parsing any percent encoding, an RDAP server treats each query string as Unicode in UTF-8 encoding. If a string is not valid UTF-8, the server can immediately stop processing the query and return an HTTP 400 bad request response. When processing queries, there is a difference in handling DNS names, including those with putative U-labels and everything else. DNS names are treated according to the DNS matching rules described in section 3.1 of RFC1035 for non-reserved LDH, NR-LDH labels, and the matching rules described in section 5.4 of RFC 5891 for U labels. Matching of DNS names proceeds one label at a time because it is possible for a combination of U labels and NR-LDH labels to be found in a single domain or hostname. The determination of whether a label is a U label or an NR-LDH label is based on whether the label contains any characters outside of the US-ASCII letters, digits, or hyphen, the so-called LDH rule. For everything else, servers map full width and half width characters to their decomposition equivalents. Servers convert strings to the same encoded character set of the target data that is to be looked up or searched, and each string is normalized using the same normalization that was used on the target data. In general, storage of strings as Unicode is recommended. For the purposes of comparison, normalization form KC, NFKC, with case folding is used to maximize predictability and the number of matches. Note the use case of case folded NFKC as opposed to NFC in this case. So it gets a little tricky there, but if I ever need to know that, I can come back and look at it again. Alright, 7 IANA Considerations. This document has no IANA actions. So IANA is the Internet Assigned Numbers Authority. So if this document did certain things, IANA would need to know about it and would need to take some actions. So IANA is a standards organization that oversees global IP address allocation, autonomous system number allocation, root zone management in the domain name system, media types, and other internet protocol related symbols and internet numbers. So here's the Whois service from IANA. We kind of played around with that a little bit yesterday. So we can see, even though they're saying it's Whois and the Whois protocol, if we actually put in a public IP, another example of a public IP would be 255.255. So it's telling me that 16/12 is reserved for private, but I'm not sure what's going on there, because we know that 3.2 is in that range. Oh, okay. I'm not sure what this is all about, because we saw in a different... Oh, you know what? Maybe it's because this actually is the Whois protocol, and the Whois protocol just is no longer being updated. Not sure what's going on there, but we saw in the last video, when there was actually a RDAP, this public IP was actually handed out to T-Mobile. Here we can see this whole block here, 172, it has been given legacy status, and then it's got a note in here that the .16/12 range carved out from this whole range here is reserved for private use. All right, number 8 is security considerations. Security services for the operations specified in this document are described in security services for the registration data access protocol, RDAP. Search functionality typically requires more server resources such as memory, CPU cycles, and network bandwidth when compared to basic lookup functionality. This increases the risk of server resource exhaustion and subsequent denial of service due to abuse. This risk can be mitigated by developing and implementing controls to restrict search functionality to identified and authorized clients. If those clients behave badly, their search privileges can be suspended or revoked. Rate limiting, as described in section 5.5 of HTTP usage in the Registration Data Access Protocol, RFC, oh, I don't have that one up yet. Can also be used to control the rate of received search requests. Server operators can also reduce their risk by restricting the number of information returned in responses to a search request. Search functionality also increases the privacy risk of disclosing object relationships that might not otherwise be obvious. For example, a search that returns IDN variants. That do not explicitly match a client-provided search pattern can disclose information about registered domain names that might not be otherwise available. Implementers need to consider the policy and privacy implications of returning information that was not explicitly requested. Note that there might not be a single static information return policy that applies to all clients equally. Client identity and associated authorizations can be a relevant factor in determining how broad the response set will be for any particular query. So security concern here, you want to make sure that you're only giving back what was asked for and you're not volunteering extra information that can be used nefariously. All right, so next section is just the references, which we already saved. Then we've got informative references. I guess I'm not sure what they mean by that, but there's also RFCs in there. There's also this PhD dissertation, which is pretty interesting, where I believe JSON was invented as somebody's. So this Roy Thomas Fielding created a for his PhD. You know, this person is only 56 years old, and really did something very impactful and significant. Yeah. It has a very short Wikipedia page, kind of surprisingly short. So, yep, one of the top 100 innovators in the world under the age of 35. That's pretty darn significant. Okay, so that's it for this video, and that's the end of reading this RFC. It looks like there's some appendixes, there's acknowledgments, but I'm not going to read any of those. So that's it for this RFC. Thanks for watching, and see you in the video where I go over another RFC.